All right, the recording is on. So if you can see my screen and the voice is okay, let's just confirm and let's get started. Okay, so today we will talk about K-nearest neighbor, and it's a very simple and straightforward algorithm, and I hope you will enjoy the session today. So K-nearest neighbor is just is part of the classification algorithms, and we can also it's quite versatile. Unlike the others, you can also use it in regression. All right. So previously we talked about linear regression. We also talked about logistic, and then naive Bayes. So today we will deal with K-nearest neighbor. So basically, what this algorithm is saying is that items that are closer to each other are similar to each other. All right, just like in the normal settings, just like you and then your family. All right, it's likely that you and your siblings look alike. All right, so something like that. So items that are closer to each other are similar to each other. All right, like there's a saying that show me your friend and I'll show you your character. All right, so items that are closer to each other are similar to each other. All right, so we use the term neighbor, right? And then there's K nearest neighbor. So the nearest neighbors are more similar to each other. All right, and the K is the number of neighbors. Okay, so it's a pretty simple algorithm and straightforward. All right. So before we start seeing how this algorithm works, let me just move on to the next slide and then. Okay, so it's something like this, as you can see on your screen. Let me bring my pen. All right, so as you can see on your screen, all right, so it's a pretty simple algorithm that if you have an item, just like this item here, X, all right, just like you have this item, let me change the color of this pen. All right, so just like you have this item here, X, all right, so can we classify this item as a strawberry or as an orange? All right, so that's basically what K-nearest neighbor tries to do. They try to match an item with a similar or with the nearest item. All right, so these are the items that are in the neighborhood. All right, these are the items that are in the neighborhood, and we try to match this item here that we don't know to each, to the neighbors, and then try to know to identify whether it's a strawberry or it's an orange. All right, and choosing K here, K represents the number of neighborhoods. So for instance, if we see K equals 3 here, so we have 3 neighbors here, right? We have two strawberries and then 1 orange here. So we have 3 neighbors here. So the K is for the neighbors, right? So that's why we say the K nearest neighbors. So these are the ones that are nearest, right? These are the ones that are nearest. So if you choose K equals 3, then this becomes the ones that are nearest, all right? And if you choose, say, K equals 5, all right? If you choose K equals 5, then you can see that we have 3 oranges and then 2 strawberries, all right? So choosing K is quite critical here. And saying that X is closer or nearer to these items is another thing that we will also look at. How do you say that X is closer or nearer to these items? All right, so we also see how we will do that. And basically we use distance measures, right? So like the distance between this item and the strawberry, and the distance between this item and this orange, the distance between this and that. All right, so if you choose K equals 5, then you, sorry, you're going to measure the distance between this and that, all right? So we use distance measures, and we will see the various distances that are being used to do this kind of calculations. All right, so before we start doing, diving deep into this, let's see some of the applications of K nearest neighbor. All right, so let me go to, let's see if I have some browser here. So I'm going to go to Amazon site, then I'll search for some items over there. Let me see what I can just search. Maybe I should, okay, there's a phone here, so maybe I should just search for a phone. Okay, so when we click on phone, right? Let me close this one so that we can actually see. Let me just search for a particular phone, maybe an iPhone or maybe a Samsung phone, right? Let me just search for something like that. Samsung mobile phone, something like that. Okay, so I'm just going to click on any of them, right? I'm just going to click on any of them. Let me just click on this. All right, then let me go down. Yeah, now we can see some items that are here. It's taking a little bit of time to load. Okay, so if we see, is someone talking? Is someone talking? All right, so let me click on this one again and then see what happens here. Okay, so now we click on this one, right? Plus protective, soft, transparent, shockproof, hybrid, blah 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 blah. Now it is giving us similar items over here. All right, it's going to fetch similar items over here. Now what it's actually doing here is that they built the KNN algorithm behind it, right? That these items are similar to this. So in case you want to buy this item and this is not actually what you really like and you want to have other options, then they will give you other options here so that you will not go away from the site. All right, you will not take the money and go away. You will still have something to choose and to buy from. Now you can see that some are phones, some are phone case, some are other stuff. All right, that they are trying to also show it to you. So these are some of the things that K nearest neighbor will help you to actually do if you study the algorithm very well. All right, it will help you to build this kind of recommendations that if someone click on an item, you can also bring similar items. All right, so let me just click on any of them here too and then see what similar items that it will start to fetch. Okay, so it will still fetch similar items and give you some other options to choose from. All right, so that's you by all means get something to buy without taking the money away. So this is a marketing strategy, which is backed by the K nearest algorithm. All right, and even if you go to newspaper sites, right, like let me search for any of them, like say the New York Times. Okay, so this is the New York Times homepage. Now, if you come here and you see up here, right, if you can see top here on the, let me bring this pen. Yeah. Now you can see that we have several items here. We have what is called the world. All right. We have what is called the world here. We have the US stories. We have the politics, the NY, the business, the opinion, the tech, the science, the health, and everything like that. Now, if you click on any of these, right? If you click on any of these, you realize that it will take you to it will actually take you to, let me just click on one of them. It will take you to a category which is similar to each other. All right, so everything here, now I just click on the science. Everything here will be relating to science. All right, so big newspapers and big news agencies like the New York Times run these kind of algorithms behind their, um, their platform. Now, if I close this and come back again, it will begin to show me science articles and science stuff. Right. This also happens on Medium a lot. All right. These are some of the algorithms that they run behind the platform. All right. So that it will begin to match and give you similar items, so that if you read one article, you will not go away. You also have similar articles to read. All right. So you can see that everything over here that they will put under science will be science related. All right. Everything they will put here under science will be science related. And these are some of the applications of the KNN. All right. So let's go back and then see how these things are worked out. All right. So as I said, this is actually done using a distance measure. All right. This is actually done using a distance measure, and we are going to see the various distances that are being used when we talk about the K. All right. So we relate the item to the neighbors. All right. And this is done based on the distances between the item and then the neighbors. All right. And we use several distance measures to do that. So let's see some of the distance measures. All right. Let me bring my OneNote. All right. So talking of the distances, right? Let me bring my pen. Okay. So there are several distances that we will touch on. All right. So first one that we will try to see is what is called the Euclidean distance. All right. So let me write it over here. It's what is called the Euclidean. Right. Euclidean distance. Let me just shorten it to this. All right, and then the second one that we will touch on is what is called the Manhattan. And throughout the machine learning, you're just going to encounter these distances over and over again, because that's what is actually being used over and over again. All right, there's one also called the Minkowski, not quite popular, but it's also there. All right, the Minkowski distance. And then when you want to learn how to build recommendation systems, then cosine similarity is actually going to be something that you really want to see how it works. All right. So we will be touching on this and then see how each of these are being calculated. All right. So let's first take the Euclidean. All right.
Hello.
Yes. Hello.
So how many distance are there? Means Euclidean distance is a conventional distance as far as we know. So as you mentioned that already Manhattan distance and Minkowski distance and cosine similarity.
Mm.
Uh, how to know that which distance is going to be applicable for which model? And
okay, mostly we use the Euclidean. All right, it's just a different way of calculating the distances, but they all work the same way.
okay.
All right, so mostly it's Euclidean. It's just different ways of arriving at the same conclusion. All right, it's just like you want to go to Delhi. All right, maybe you are at Bangalore. You want to go to Delhi. All right? There are several ways of going there. You can take you can just take an airplane, or you can just take a train and then you go, right? So there's several ways of arriving at the same thing. So it's not like the algorithms that you need to know whether you have to use classification algorithm.
It's 9 o'clock.
Whether you have to use classification algorithm or you have to use clustering or regression, right? They all work the same thing. They all find the same thing, just a different way, or different people that sit down and come up with different strategies together. All right. So let's say we have a point. We have a point A, right? We have a point here. Say a point A. All right. So this will be, say, x1. All right. Say x1. Right, and then y1. All right. And then we have another point, say point B here. Say S2 and then Y2. All right, so what Euclidean distance is trying to do is to try and then find the distance between these 2 points. Why is my pen disturbing me today like that? Okay, so what Euclidean distance is trying to do is to try and find the distance between this, right? Distance between A and B. All right, so what Euclidean distance is saying that the x1, right? So you pick x1 minus x2, all right? You square it, plus, so this is a square, plus, and then y1 minus y2, then you square it, all right? Then you find the root of that. This is what the Euclidean distance will actually do to find the distance between A and then B. All right. And then for the Manhattan, right? For the Manhattan. Now, if Manhattan was just used based on the city of Manhattan, just like there are several buildings like that, all right? There are several buildings. Maybe one will be here. And then maybe there's another building here. Something like that. There's another building somewhere here. Something like this, all right? And then maybe you want to move from this building to this building, all right? And if let's say here is something like a river, all right? So maybe what you can do is the road will be something like this, something like this. So unlike this one that you can just go straight, right? This one is saying that you can just pass in between the houses and then you go, all right? Something like that. So what Manhattan would do is very simple. It's actually simpler than the Euclidean. All right, so what it would do is that it will just find x1 minus s2, actually s2 rather, minus s1, and then find the absolute value of that. You can use s1 minus s2, since you will find absolute value of that. It's still going to be the same thing, all right? And then you can find y1 minus y2. Right, it could be y1 or y2 minus y1. Either of them will work, because at the end of the day, you find absolute value of that. All right, so all the negative distances will be positive, right? There's no negative distance. So whether you start with s2 minus x1 or s1 minus s2, all works the same thing. All right, so that's how the Manhattan also works, right? And for the Minkowski, right, for the Minkowski, what it's saying is that you find this, just one of these, right? So let's say from point A to point B, right? So for it will not actually do it like this and square it and find the root of that. It will just say that, okay. Oh, why is my pen disturbing me today? So it will just say that x, let's say x2 minus x1, all right? And then it will just generalize it. So generalizing it, to just use just a variable here, and then do so for all of them. So maybe we have another point, not just points up to point B. Maybe we have another point C here, right? So maybe we want to move from point A to point B and to point C. All right. Maybe there's another point D here. All right, something like that. So it will sum all the distance between A and B, distance between B and C, and then C and D, something like that. All right. So you will sum all of them like that. You find all the distance. So this could be, let me use xi, and then maybe sj, something like that. All right. And then this is just the exponent of it. So the exponent could be 1 or 2 or 3. And if it becomes like say xi minus say xj, all right, and then here is 1, then if you sum this one, if the points are 2, then you are actually finding this, you're actually arriving at this, which is the Manhattan. All right, then you are actually arriving at the Manhattan. And if this point, this here, this p, which is just an exponent, if it becomes like it becomes like 2, then you are still arriving at this. You are still arriving at the Euclidean. So this, the Minkowski is actually a generalization of the Manhattan and then the Euclidean. All right. So mostly, since they all work the same way, since they all find the same thing, we mostly use the Euclidean distance. All right. But when it comes to recommendation systems, there's also a caveat. There's some shortcomings when you use the Euclidean distance. So when it comes to recommendation systems, so you're finding distance to make some building recommendation systems, then the cosine similarity is actually going to be very helpful. All right, cosine similarity is actually going to be very, very helpful. So let's see how that one also works. So let's say we have points, we have one point here, we just say A, and then we have another point here, which is say B. All right. Now, if we draw the axis, like say this is X, right? And then this is Y, right? We can trace this one here. Let me say a line. I'll work best. So let's say this one, all right? Okay, let me bring another line here. Okay, so what we are going to actually do over here is to find the distance between this A and then B, all right? Between the A and then B. So we find the angle here, right? The angle theta, which is between A and B, all right? So that is going to be like this, cos theta, all right? So that's why we call it cosine similarity, right? So we just measuring the distance between A and B, all right? The distance between, oh, come on, this pen. The distance between A and B, all right? That's what we want. So we measure this angle. So the closer the smaller the angle, right? The closer these items, right? So the closer these gaps, then you can see that they are more closer to each other. So if we have another one here like this, and then let's say we have point D and then point say F, right? And then if we trace this here and then trace this here, right? Definitely the angle here is going to be very big than this. So this A and B is going to be similar to each other than D and then F. All right. So if we bring another point, let's say we have another point E here. All right. And then we trace this one too. And then we find the angle between this D and E.
Hello.
Yes, hello.
So this A and B are the data points,
Yeah,
right?
yeah.
So here the origin, I do not understand that in particular in real data. So if between two data points there is an angle phi. So
Yeah.
what is the origin is taken for that data set, or means by what respect?
So
What is the
what's in real data points, what it will do is to calculate the vector. All right. So
yes?
this is actually going to be in a vector form.
Okay,
It's actually going to be in a vector form. Everything will be converted into a vector form and then calculate the angle between that.
okay. So in KNN nearest neighbor, the distance user is used in Euclidean, right?
Yeah,
So
we are going to use Euclidean distance actually.
so what are these other distances going to be applicable for which? Uh,
Okay, these are all other distances that you can also use, right? So just in case you meet it anywhere, you can actually you become familiar with it, and not that is the first time you're hearing it, right? All these are other distance measures that you can use, apart from the Euclidean. All these are other distances that you can use. And as I said, if you are dealing with um, recommendation systems, right? If you're dealing with recommendation systems, then cosine similarity is actually going to be handy, all right? Cosine similarity is actually going to be very, very helpful.
and what is recommended system? Yes, I don't have any
Okay,
idea.
like you go to any site, right? You go to any site and then you want to buy something. Then they will say that those who buy item A also bought item B, right? They are recommending item B for you. Maybe you want to buy a phone, right? You want to buy Samsung phone. Then they will also show you that, oh, those who bought Samsung phone also bought Samsung maybe charger, right? Then they will bring a charger up for you. So you want, your intention is to buy phone, but they are now showing you charger. So they are recommending charger for you.
Okay.
All right. Or otherwise, if you go to a platform like say Medium, all right. If you go to platform like Medium to read some articles, then they will begin to show you some other articles too. So maybe you want to read article about KNN, all right. You want to read articles about KNN. Now, whilst you're reading articles about KNN, they will also show you articles about naive Bayes, right? They also show you articles about naive Bayes. They also start to say that maybe 500 people have read this article. They will show you some similar articles, all right? So they are recommending some articles for you, right? Just like, okay, you go to, if you go to Flipkart, all right, you go to Flipkart, and then maybe you want to buy something like maybe like tea, right? Like tea powder, right? Then they will begin to show you sugar, something like that. So your intention is to just buy some tea bags, all right? To buy some tea bags and go, but they will also show you some sugar, because they know that most people who buy tea bags also buy sugar. All right. So recommending sugar to you is a form of recommendation system that they've built behind the platform, which is matching your interest with some of the items that you may be interested in also.
So I have a question that for
Okay.
every other distance I have to code particularly according to the model, or the distances will be available already in code. Means,
They are
uh,
already there. They are already there. And you don't need to actually calculate it by hand.
oh, okay.
Yeah, you are not actually going to calculate these distances by hand. It's already inbuilt. Like if we take the KNN, for instance, it's already there. But you need to know why it is doing that and what is behind that. Right. That's why we are learning this. Right. If for instance you want to go for any data science interview or something like that, they want to know if you actually understand what you're working with.
Okay.
All right, so you need to know that matching say matching sugar with tea bags, right? What is the reason behind it? They want to know if you know what is behind that,
So
right?
this answer will be like I can use cosine distance, right, in that case for recommended system.
Yeah,
If
in recommendation system, mostly we use cosine similarity.
okay.
Like if you order something from, let's take Uber or maybe any food app, any other food app like Zomato, right? If you order something from Zomato, Zomato cannot move from that restaurant. Maybe let me push down here. Maybe we have a restaurant here, right? Restaurant is somewhere here, right? Then they are cooking the food, maybe some whatever food they are cooking, right? They are cooking it over there. Then your house is somewhere here, right? Your house is somewhere here. Now, if you order something and then the Zomato guy go here and then collect the item, they cannot just come straight to your house and bring it, all right? So how would they do it? They will pass in between some houses, all right? There will be some houses which are here, some houses which are there before they get to your house. But how would the app actually calculate this distance and know that within 30 minutes you will receive your order? All right, how would the app actually know that within 30 minutes you receive your order? So that's basically what it will do. It will use, say, Manhattan, right? To use Manhattan distance to calculate this and then know that within 30 minutes or within 45 minutes, you're supposed to receive your order.
Okay.
So maybe you're going for an interview on, I mean, at Zomato or something like that. These are critical questions that they might want to ask you as a data scientist or data analyst.
So I have a question out of that context that how much the ability of code is important for the data scientist. As a data scientist, like I have no prior experience in statistics and all. Like I'm learning
Okay,
now.
so for instance, you want to calculate the, say, the mean, maybe the standard deviations, the quartiles, the whatever that you want to calculate. The good thing is that all these things are inbuilt, right? There are some functions to calculate all these things, all right? So you don't actually need to be a hardcore statistician or some supernatural statistician to do these things, right? You only need to know what you need and what you can use for, right? So if you want to, if you are working at a shop, maybe a boutique shop or something like that, as a data scientist at a boutique shop, now you want to help them and then make them sell the items that people buy the most, right? You want to help them so that they actually sell those items. Now, if it is a boutique, they actually need to place the items, like Walmart, for instance, right? They have some items that they placed in front of the shop and those that they place at the back of the shop, right? So items that people buy the most, you find them right in front of you, right? Like food items and stuff like that. All these are analysis that they do. But how do you, as a data scientist, do that? All right, then you have to know that the items that mostly or frequently appears, you use mode to calculate that. All right, so that's what you as a data scientist need to know. What is mode, right? So mode is item that mostly or most frequently appears. All right, so you get their data and then you calculate the mode on that data. All right, so maybe when you calculate the mode, maybe you find that women hair, maybe ladies hair or something like that, are the ones that people buy the most, right? So these are items that they will hang in front of the shop. So you as a data scientist, that's your work, right? That's your work, and then you actually need to know what is mode and what does it do. I mean, so that's the kind of statistics that you actually need to know. Not that you have to um, know some of the some hardcore statistics or something like that. You need to know what you need when the situation is there. And for instance, if you want to calculate the mode, for instance, you're not actually going to sit down and then use that hand calculation that we do in our universities or in our 12 or something like that. You just there's a function there that you just use, right? That you can just use to calculate, and then you get it. All right. You don't actually need to do these things by hand. but you just need to know how it works. All right.
Okay.
Okay. Is there any other question, or we can move on?
Yes, we move on. I will ask you at the end of
All
this.
right. So talking of the distances and stuff like that, you actually need not to worry about that because you're not going to do all these things by hand. All right. But you have to know the distances that are actually being used. Right. So there are some that will prefer to use the Manhattan. There are some that will prefer to use the cosine and the Minkowski. All right. So when you hear about these terms, it shouldn't be a bother to you, or it shouldn't be a new thing to you. All right. So let's move on, and then before we go there, let me point this one out. I don't know why my pen is keeping on picking eraser. Okay. Let me go down here. Now you're picking the K, right? So you have some items and then you pick the K to calculate it, right? Now, if you pick K to be say 2, right? If you pick K to be 2, possibly you will not actually have it. You will not have this one there, right? Or one of these there. You might have 2 neighbors, right? So now if you have 2 neighbors and you have your point here, which one would you assign your point to, right? You cannot say that this x is for this or is for that, all right? Even if you use the distance, right? Sometimes you might end up having the same distances in between them. Okay, so mostly is good if you choose k, to be an odd number, right? So that you can actually break the ties. So k can be say 3, 5, 7, or something like that, right? But if you choose k to be say 2, and then you have a point in there, it's going to be difficult to assign the new data point to either of the neighbors. All right, so it's good if you choose k to be an odd number. All right, so let's get hands on and then see how these things are being used. All right, so let's get to the code and then see how these things are being used. And before we go there, let me just point this one out too. If you choose k to be very, very small, like say k equals, let's just say k equals 1. All right, if you choose k equals 1, it means that let's say we don't have all these there, we don't have this one there, we don't have this one there. All right, so automatically x is a strawberry. All right, if you choose k equals say 1, automatically x is a strawberry, but it might not be the case, right? X might not be the case, but because you choose k to be 1, right? So choosing k is very critical. And if you choose k to be say very large, right? Maybe k covers something like this, maybe something like that. All right, very large. It means that the items that are dominating, right? So let's say in this case, orange is dominating. So automatically X here is going to be an orange. All right, so 1, choosing K to be even number, all right, it's not appropriate, all right? And choosing K to be very small is not appropriate. And choosing K to be very large is also not appropriate. All right, so there's a way to choose K, and I will show you in a couple of while. All right, so you have to be very critical when you're choosing the K. Okay, so let's get to the code and then see. Let's do something here. All right, so we are going to work on this breast cancer data set. It's actually available on the UCI repository, so you can get it from there. If you get the notebook, I've put the link there. I also put the data set itself for you so that you can easily get it. All right, so we're going to work on that data set, and basically what we want to do, all right, if you see the data attributes in there, let me bring the pen and show you. we can see that we have sample code number is just an ID that they gave. All right, it's just an ID that they gave. Then we have clamp thickness, uniformity of cell size, uniformity of cell shape, marginal adhesion, single epithelial cell size, bare nuclei, bland chromatin, normal nuclear, and then mitosis. All right, so let me just load this data set so that we will get to see how it is. So first we will actually have to import the various libraries that we will be using. All right, so I'm going to import NumPy, then I'll shorten it to NP. All right, then I'll import pandas, then I'll shorten it to PD, then I'll import say Seaborn, all right, then I'll shorten it to SNS, then I'll import Matplotlib, .pyplot, and what else? Okay, the rest of them I will import it when I need it. All right, so let me run this and see. Okay, still running over here. All right, done. So there's another way that you can do, right? You just use PyForest. You can just get everything. All right, so let me do it like that. You can also use from PyForest. You can import. Then you import everything. All right. And then if you use this to show the various libraries that you've imported, so let's import. You can see that automatically everything has been imported, right? So without me doing it one by one like this, maybe I will need even more of the libraries. So without me doing it all of them one by one like this, I can just use this single one, just this PyForest, right? Then I'll get all the libraries imported. Right? Oh, these are the common ones, right? Maybe some of them will not be present, but these are the most commonly used libraries that you can easily use just this PyForest. So if you don't actually have PyForest, you can just use this pip install PyForest. All right, then you install it. I have it, so I'm not going to run that. All right. So let me comment that so that when you get the notebook, you can easily use it. Then let me comment this one too. Okay, so let me load the data set into a variable called df. So I'll use pd.read underscore CSV. I think it's a CSV file. And the name is actually something weird. This is just the name of the file, all right? You can rename it to the name that you want. All right, so loaded. Let's see how this data set is looking. Okay, so this is how our data set is actually looking. All right, guys, can you see my screen? Sanjay, okay, I was not actually looking at the chat. Okay, so we'll go to how to choose the K, all right? We'll come to that. All right, good. So let's continue. So this is how our data set is. So as I was saying, this is just an ID. They have an ID there. That's some diagnosis over there, and then some radios, man, blah 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 blah. A lot of stuff over here. All right. So in this case, the target is just this. Okay, I think let me see this. Let me copy this diagnosis here. Okay. Okay, so this one is to actually to predict whether a cell is malignant or benign. All right, so let me just put that one here so that it will be a reference instead of this. Make it work. Predicting whether a cell is malignant or benign. So let me do it that way. All right. So this is more like a categorical, right? So whether it's benign, so B for benign, and then M for malignant, right? Malignant means that the cell is actually cancerous, and then benign means that the cell is not cancerous, it's a good cell. So that's what we're going to predict using the K nearest neighbor, all right? So the diagnosis is actually our target, right? That column is actually our target column. So let's see what we can actually do with this kind of data set. So let's see how many rows and columns are there. Let's use the shape and see. So we have 569 rows and then 32 columns. All right. So we can also check the data type. Let's see D types. Okay, so we have int in 64. Obviously, the ID is an integer, right? If you see it over there, it's an integer. This is supposed to be a categorical, right? It's supposed to be either B or M. So it's a categorical. We will change that. We will change that. And then this is float, 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 all of them, right? All of them are just floats. Like up to the last one, all of them are floats. So checking the data type is cool. I think everything is fine. All of them float. So let's go and then change this diagnosis to a categorical type instead of an object. All right. It's treating it as an object, but we want it to be categorical. So I'll pick that, which is the diagnosis, and then I'll just convert it. So I can do dot diagnosis. Then I'll change the type using the as type. As type categorical. Let's see what is in categorical. Okay. So let me see my spelling category. I think I should do it that way. Okay, good. Now let me check the data type again. So df.dtypes. All right. Okay. So now is category, not an object as it was given us. All right. So we can like you were saying, we were talking about the mode and those stuff. So we can just use describe, and then we can get to know a lot of stuff here. Let's see what is there. Okay, let me just transpose this so that I'll use .t here, transpose it. Okay, so now this one becomes a little bit explicit for us. So this one is giving us the count. Obviously, they are all 569, as we saw from here. 569 rows, all right, they all consist the same. So the mean of each of the columns will be calculated, the standard deviation, the minimum, the maximum, the Q1, all the way to Q3, right? Q1, Q2, Q3, right? So the first quarter, second quarter, and third quarter, all be calculated for you just using the describe, right? So this is a whole lot of calculations that you could have done with hand, but with a function like this, you just calculate it, right? So if they say that what is the maximum radius mean, you just use the describe, you get to know that the maximum here is 2.811. All right, so you don't actually need to be doing this by hand. You just need to know that when you want something like this, what function are you supposed to use? All right, so let's see what we can also do. Maybe we can check to see if our categorical column is actually balanced. So I'm going to pick that. And then I'll use the value count, value underscore count. Okay, so in this case, we can see that we have 357 benigns and 212 malignant. All right, so it's quite okay to make the predictions on it, unless if there's maybe three in 300s, right? So 300 and above, and then maybe we have M to be say 60 or 70 or something like that. Then we need to make sure that this categorical column is balanced. But in this case, it's okay. 300 and 200 is fine to make predictions on. All right. Now we have an ID column here, which we actually don't need that because we are not going to make any predictions, or it's not going to contribute in any way. This is just an ID that they gave, right, for each of the data points that comes in. So we're going to drop that part so that we can move on and then prepare our, what do you call it, prepare our model. All right, you can also do some visualizations if you want to do that, right? In this case, I mean, we've been doing that in our previous project, so we'll move straight forward to see the KNN here. All right, so let's prepare the data and then start using the KNN. All right, if you want to do visualizations too, you can use the Seaborn, you can use a disk plot, you can be using all the pair plots and those stuff to actually see how the distribution of each column is doing. All right, so let me drop the ID. I'm using labels equals the ID. You can skip the labels and just write ID and specify that it's in the column by using axis equals 1. All right. So now if I do dl.head, you can see that we don't have the ID there. Okay, so if you remember the last week we were talking about dividing our data set into dependent and then independent variables before we start to if we want to perform scaling something or normalizing our data, we can do that so that we will prevent what is called the data leak. All right, so in this case, we are going to divide our data set into dependent and independent. Right, if you see the data points in here, right, if you see the data points in here, you can see that there are some of them which are high values like 12, right, some 12, 11, something like that. There are some which are very, very low, like 0 point something, all right? So we need to normalize it so that they will all be in the same level, they will all be in the same scale, all right? So that's what we're going to do. But to prevent our data from leaking or from preventing the testing data so that our model will not learn from the testing data, we're going to separate it and then divide it into dependent and independent. So over here, this diagnosis here, all right, this diagnosis is actually going to be our dependent. All right, it's going to be our dependent. And then all these from here to the last one, all right, from here till you go all all the way to the last column that you will see over there. All of them are going to be independent variables, right? So this, we will name it X, and then for this, we will name it as Y. All right, so that's what we are going to actually do. So let me do that one here. So my X, instead of picking everything one by one, like radius, texture, everything, like I can actually pick them, say radius, radius underscore mean. So I'm picking this one, right? I'm picking this one. So we can actually pick them one by one like that. Then I pick the next one. Then I pick the next one. Texture T here, right? Then I pick the next one. I mean, it's going to be a tedious work till I pick all the way to here, right? All the way to the last one. So in order to just save myself, I'm not going to do all this. Right, so I'm just going to drop this one, and then the rest of it, if I drop the diagnosis, the rest of them are the independent variables, right? So I just drop the first one and then save the rest in what is called the X. All right, so I'm going to do df.drop. I think someone's microphone is on. If you're not talking, please, you can mute yourself. So I'm going to drop this, specify that in the column. So if I drop just the diagnosis, the rest of them are called, the dependents, right? The rest of them are the dependents, okay? So apart from this, right, if I take off this column, then I pick everything here all the way, right? And store it in X. That's what I'm doing over here. Then after that, my Y, I'll just pick only the diagnosis. Let me just copy it and bring it. Yeah, I'll just save this one in there. So done. Now if I just show you X here, you can see that X starts from the radius, right, without the diagnosis, right? It starts from the radius all the way to the rest of them, right? All the way to dimension waist. That's what we want. We want to pick everything to dimension waist, with the exception of diagnosis. Now, if we see the Y, right? Let me clean this one and put Y there. See that Y consists of only the B and blah, 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 which is only the diagnosis. Okay. So now let's see what we can do after this. Now we can scale our data without without causing any data leak here, right? And I'm going to use the z-score. The other time we used standard scalar. So this time I'm going to use the z-score. Let me just call it as scaled. And I'm going to scale the X. I'm not going to scale the Y because it's just categorical column, which I don't actually need. So I'm going to apply the z-score on it, on the X. Blah, blah, blah. Okay, I have to actually, I have to load this data set, this library, this z-score library. So I'm going to do that over here. So z-score is actually in SciPy in stats. So from SciPy.stats, I'm going to import z-score. All right. Okay, so now done. Now if we see this scaled that we did, so this becomes our new S, right? See that they are all having small values with with similar variations in here, right? With none of them being so high, none of them being so low, right? So with this, we can actually have a fair, we can actually have a fair model built on it. Now, if we had forgotten about this scale and then use this, as I was talking about the Euclidean distance, all right? So that's what is going to happen here. It's actually going to use Euclidean distance and then calculate the distance between this point, right? This point and this point, and then this point and this point, this point and this point, to do it for all of them, right? Now, if we just take this point, yes, this point and this point, and then it will calculate this, then it will calculate that, then it will calculate that. It will calculate this and then square it, all right? Square everything, all right? And then add it. That's the Euclidean distance, right? Then it will do the same thing. Now, if you see the distance between this, right? The distance between the huge values and the small values, right? This is going to be very, very, very small. So this is not actually going to be counted, right? It will ignore this and then take the like 461 64.1 and then 346.4. This is a very huge one, and if you find the distance and square again, it's going to be very, very huge, right? Which will overshadow this one, okay, which will overshadow this one. So the importance in this, the information that we could have gotten from this one is going to be ignored, right? And that's what we don't want to do. That's why we scale it or we normalize it, right? And if you're doing that, you have to first make sure that you separate your data into dependent and independent. Okay, so that's why we did over here, so that now you can see that no distance will actually outweigh the other. All right. Sorry, no distance over here will outweigh the other. So let me get rid of this one so that we can actually have space. Yeah. Okay, so now we have scaled our data. Now we have we can even do we can do the describe on this one also. All right, we can do the describe on this one and then see the standard deviation and see. So let me just copy this one. Don't want to type over and over again. And then use the describe and then see what is the standard deviation we're having over here. Okay, now you can see that they all have the same standard deviation over here. All right, so no distance is going to outweigh the other. Let me clean this thing. Okay, so now if you see the standard deviation, right, you can see that they all have almost this, I mean, they have the same thing, not almost, but the same thing, right? They all have the same standard deviation, right? They all have the same standard deviation over here, okay? So now no distance is actually going to outweigh the other distance. We can show the pair plots. It's actually going to take a little bit of time, but let me just try and see the correlation that we're having over here. If we need to do something, if they are more correlated, then we actually need to do something. So before I can use that, I think I have to convert this into, yeah, I have to convert it into a data frame. All right, so let me do that first. So I'm going to use skilled underscore df, right, so representing data frame. So I'm just going to convert everything, right, into a data frame, to a beautiful data frame. So let me do that. Ad dot And let me put my SQL here and run. Okay, good. Now I can use it over here. I'm just going to show this one and see how it's looking. Or maybe print the, let's see if this one will work. Come on. Okay, good. Now everything is killed and everything is good. We can now work on this. All right, so let me use that one and let me use this and see if I can get a pair plot for that. So for the diagonal, I want it to be a KD. I want it to be kernel density. So if I run it, it's going to take a little bit of time, right? Considering the data points that we have, it's going to take a little bit of time. So before as it is building, let me convert this one to a markdown and then we can do something. It's going to do it. So after that, we'll come back and look at what it's doing over there. So let me convert this to a markdown. Okay, so here we are going to use the train test split, right, to actually make the splitting here, right, to split our data into training and then testing, right. It's important using the Py for it, but I'm just going to write it here so that you know what I'm using. So from scikit-learn, right, from sklearn, from sklearn.model selection, and the underscore selection. I'm going to import what is called the train underscore test underscore split. All right. Okay, so that's what I'm actually going to use to split our data set into training and then testing. Okay. So it's actually taking, the pair plot is taking a little bit of time to do it. So let me just go ahead and then do this X underscore train. So I'll store those training data that I'm getting from X in what is called X train. And those that I will use for testing, I will store them in what is called S test. And those in Y that I will use for training, I will store in what is called the Y train. And those that I will use for testing, I will store in what is called the Y test. All right, so I'm going to use this. And then I'm going to pass in my X and then my Y. So in this case, we have actually scaled it. So we named it this. After scaling it, we named it and put it in a data frame. So I'm going to use that. And then the Y. And then I'm going to use 80-20 or maybe 70-30. All right, so let me use 70-30. So test size, 70 for training, 30 for testing. All right, so I'm going to use 0.3. And then I want, this is going to be done randomly. All right, so I want to have the same random variables when I run this over and over again. All right. So this is still working. If you can see here, Python 3 is still black here, still working because of the payload. All right. It's going to actually take a little bit of time. I think it's now about to display. So we give it a little bit of time, and then so as it's taking time, let me continue writing this. All right. So let me just initialize our model, and then let me save it in what is called KNN. Okay, so let me see with this lazy import if it actually got KNN for us. Oh, okay. This one is still running, so it's still going to take a bit of time to show us. Okay, so let me just write that library as it's still taking time. Let me just write it. All right, so I'm going to use from sklearn dot neighbors. I'm going to import what is called the K neighbors classifier. Oh, this thing has taken a lot of time. So I'm going to initialize this. I'm going to initialize this one here. Or maybe I can just interrupt this as it's taking time and then we move on. Let me just give it a little bit of time. Let me just move on, and then as soon as it's ready, we'll go back for it. So n neighbors here is actually going to be I'm just going to give it 5. I mean, the number of neighbors, if you remember, we talked about how to choose the neighbors, right? And you have to be careful when you're choosing the neighbors, right? So in this case, I'm going to start with 5, but later on, we will verify, and then I will show you how to choose this 5. I mean, how to choose this K, right? So this is the N neighbors here. This is the K, right? So in K neighbors classifier, we have it to be and neighbors. All right, so this is the number of neighbors. So in this case, I'm just choosing 5 randomly. All right, later on, I will show you how to choose this one. All right, I will show you before we close this. I will show you. So let me randomly choose that and then do this. I think I have to interrupt this. It's taking too much time. Let me just go and interrupt this kernel. Yeah, so let me just comment it. Okay. Now let me run what we're doing. We run this model, run this, that's okay. Now what we have here is weights. Okay, so now over here I just split our data set into training and then testing. All right, then coming down here, I am just initializing our key neighbors classifier. All right, so this is the package that you use when you are dealing with key neighbors. All right, so you will not be doing the calculations that we did. All right, everything is being inbuilt here. All right, and then I'm seeing that give weight to the distance. All right, so the more closer the item is, the more important that item is. All right, and I'm just choosing a random K here. Right, so the number of neighbors, I'm choosing it to be 5, which is randomly choosing, but later on I'll show you the best way of doing that. All right, so let's go and then use this initialization here to learn from our data. So I'll use .fit, right? So in this case, it's going to learn from the X train. So this is where the machine learning starts, right?
It's 10 o'clock.
It's going to learn from the S train and then the Y train. All right. So if I run this, done. Now we can actually see how our model is doing. All right, so let's use it to make some predictions. So I'm going to use KNN, or maybe make it caps, KNN underscore predictions, or just make it predict. All right, then the model that we built, which is KNN. So this becomes our model, okay? The KNN is everything that we need here. That's what we are going to use to make the predictions. So I'm going to make some predictions on the testing data, all right? On the X test. Remember our model did not learn from the testing data, so I'm going to use that one to make some predictions. Now, the predictions are stored in this, so if I run that, you can see that it's predicting some M's and some B, and that's what we want to do, right? We want to predict whether the cancer is malignant or benign, right? Whether it's M or B, all right? So it's predicting some M's and some B's here, right? Saying that some of the cells are malignant, some of them are benign, and that's what we want to do. All right, so our model is actually working fine. Now we can actually check the score, right, by using knn.score. I hope I have imported this .score. So I'll check it on the S test, test, and then the Y test. Okay, so we have 96% here. All right, we have 96% here. So let's try and then build a confusion matrix and then see the number of, how well it was able to predict and the mistakes that it was doing. So from sklearn, I'm going to import metrics. Okay, so let me write this thing. It will make sense in a moment to you. I'm going to use metrics. And then in metrics, I'm going to use confusion matrix, confusion underscore metrics. And then I'm going to pass in my Y underscore test and my predicted variable. And then I can set the labels for this. Set it to M. We have M and B. So I'll set it to M and B. Then after that, I can put them in the data frame. So data frame of this CM, let me name it at the FCM. PD dot data frame. So I'm going to convert this into a data frame. And then I'll set the index for this. So let me write some for loops here so that's I in this labels. Okay. I'm supposed to come. Then I'll set the columns also. Then I'll set a column name. So this will be my predicted M. Then I'll have my predicted. Well, I need to put it here. B. I think I still have one here. Okay, so let me see what I can do. Put them in a heat map. So I'm going to use Seaborn. And then in the heat map, I'm going to put this data frame in there. Okay, let me do this and see what I have. Evaluate syntax, I for, okay, I for I. That what else? White tests. Test. Okay, so now we have a beautiful confusion matrix here. Let me show the numbers in on it. So I'm going to use I think it's a note, yeah, a note equals true, so that we see the numbers on it. Yeah. Let me try and put a title there. It's confusion matrix. Okay, good. Do plt.show so that I'll get rid of this. Okay, fine. Now, let me zoom out a little bit. Guys, can you hear me? Can you hear me clearly? Okay, all right. So let me show you what our algorithm is doing here. So for them, right? So we made some predictions. That's what I wanted to show, right? Because I said we measured the score and then we got 96%, but we don't actually know how many right and wrong so that it was able to do. So if we see this here, all right, we can, let me use blue. We can see that for the M, right, for the M, our algorithm was able to classify 53 of the M's as M, right? We were able to predict 53 of the M's as M, right? And some of the M, 4 of the M's, right, our algorithm, instead of predicting it as M, right, we predicted those 4 as B. Instead of M, we predicted 4 of them as B. So 53 of the M's, we were able to predict them as M, right? And then 4 of the M, we predicted them as B. So see the black ones as the mistakes that we did, right? So for the M, we did 4 mistakes. We predicted 4 of them wrongly, right? And then for the benign, right, for the B, this is just 1.1 E plus 0.2. I'm just writing what is here. So it's just 1.1 multiplied by 10 exponent this, right? So it's just like 110, okay? Something like that. Remember, we have more B's than M's, right? So for 110 of the B's, we're able to predict as B, right? We were able to predict 110 of them as B, and only 2 of them that instead of B, we predicted them as M. All right, so maybe instead of showing you phones, maybe you search for phone, right? Instead of showing you phone, wrongly it showed you phone cover. Or maybe you search for Samsung phone and then it showed you some iPhones, all right, some 2 iPhones. So that will become a wrong classification, right? But at most of the time, it was able to show you phones. I mean, Samsung phones are Samsung phones when you search. All right, something like that. So that's how you can think of it. All right, so we're able to wrongly classify 4 of the M's as B, and then 2 of the B's as M. All right. So now let's see how we can actually choose this
Hello.
this K rather. Yes, hello.
Could you please explain that code above where you have used the looping technique in I for I in the and columns I for I in
Okay,
predict?
okay, okay. So let me zoom out a bit, yeah, and then bring my pen. Let me see what I can do. Let me try and get this clean my. Okay, so just give me a moment. I just want to clear this screen so that let me quit this and then I'll bring it back again. All right, let me see. Yeah, now it's fine. Okay, so let me go and pick this blue here. Okay, can you see the pen now?
Yes.
Okay, good. So what it's doing over here is that I just want to draw this, right? If I just use the confusion matrix, I'll have something like this. It will show me something like 53 and then 4. Then it will show me 2 and then 110, something like this is all that it will show me, right? It will show me some matrix form like this, right? But I want it to be in a form like this, right? I want it to be drawn nicely like this. That's what I was using all these things. Okay, that's what I was using. So over here, I could have just used matrix.confusion matrix and then just put in these things and then do it. But let's go through one by one and then see what was happening here. So what I did is that we have this matrix, right? And inside the matrix, we have what is called a confusion matrix. Just like we're using all the algorithms in the algorithm, you import the package and then you used what is inside that package. Like for instance, we say that from sklearn, right? Then we import the k nearest neighbor. Then after that, we use the k nearest neighbor to perform the algorithm. So confusion matrix is inside this matrix, right? And that's what I'm using here. So matrix.confusion matrix, right? And then the y test is just the y. We divided our data into testing and training, right? So the y test is just part of the
So
testing.
this training and testing sample data is selected by a machine by itself, or
Yeah, randomly selected. We don't do that explicitly. You can do that by hand, but if you use the train test split, that's why up there, let me clean this and go up. That's why over here, where we split, yeah. If you can see here, I'm using something called train test split. So this
this
package is doing that randomly without me using my hand to do that. So it will just use, and then over here, I specify that uh,
right?
over here, I specify that I want a ratio of 70,
Mhm.
30. So I'll use 70 for training, then I'll use 30 for testing. Okay, that's why I say that the test size should be 0.3. 0.3 is just like saying 30%. So over here, I put that y test is here, y test is here. This is where I got the y test from. So I put the y test there, and then this is the predicted, so that I will be able to know which one I predicted right and wrong, right? So I use, if you remember, we make some predictions here using our model knn.predict. Then we store the predictions in what is called the knn underscore predict.
So predict especially on testing data set
Yeah,
where
yeah. You make predictions on testing data set, not on training data set, because your algorithm or your model has already learned from the training, and you don't want to use that for testing.
okay,
Otherwise, you end up your model will end up performing very well on the training because it has already learned from it. All right.
okay.
So there's no need using the data that it has already learned from it to make testing, right? Just like you give the student the question paper, and then for after 1 month later, you will say that the student should come and write the same paper. The student will maybe score 100% or something like that, but there's no need doing that. So you use testing paper, like a test question paper, which the student has never seen before. So the same thing that we did over here by using testing, right, using the test data. Okay. Then after that, I'm setting labels here. The label is just labeling this as B and then M, right? That's what I'm doing over here. Then
So
I come.
so here automatically y test is labeled as M and KNN predict labeled as B, right?
Yeah. Then over here, I stored everything here. I stored everything in CM. Just confusion matrix is just a variable name. So over here, you could have just maybe choose confusion, right? Maybe confusion M, something like that, any name at all, right? But I just shorten it, confusion matrix to CM, right? Then I'm saying over here, I'm converting everything into a data frame, all right? So this CM is the same thing I put here. Then I want to set an index, right? So I already have set the labels to M and B. So I'm saying that for any item in M and B, right? So there are some items here for M, there are some items in M, right? And there are some items in B, right? So for any items, they set a column for it, set column names for it, and I want to set this my predicted M and my predicted B. All right, so set that for me. All right, that's why I'm using the same I and the same I here. All right, so M here will be my prediction, and then the original B and M will also be here. So that's what this part is actually doing. And actually, this one, you can use it over. Heat map is also a function that you can use to get the colored one like this, instead of just allowing, if you draw ordinary confusion matrix, as I said, you're just going to get 53 and then 4 and then 2 and then 110, something like that. You're just going to get something like this, right? But in order to get it in a drawing form, a beautiful form like this, so you use heat map. So this is just called heat map, right? Drawing it in this way and having a label like this is called a heat map, all right? So that's basically what I did. So after that, after converting it into a data frame over here, I just put the data frame there. And then in order to see the numbers on the data, on the heat map, I just put annotate equals true. All right, and then when I printed, I was having some other stuff here, so I just want to get rid of that. Then I use plt.show, all right, to just show everything that I'm doing. Okay.
Yeah.
Okay, so now I randomly I chose k to be 5. All right, I chose k to be 5 here. Right, then the neighbors, I just said that 5, right? Like this, in this case, I just chose 5, but I don't actually know the k that I'm supposed to choose. It could have been, say, 2 or 4 or maybe 20 or something like that. I don't actually know, so I just randomly say that k equals 5, right? So in order to test which k to use, well, I'm just going to write some for loop, all right, which will help us to know the kind of k to choose, all right? So this is kind of a test that you can do on your data set when you're using KNN to get the best k, all right? And you can use it over and over again. So I'm just going to write it here for you, something that I use when I'm using.
Hello.
Yes, hello.
Hi, this is Sanjeev. So before going to this K, can you please tell me that which distance we have used, just to go back to that knn.fit?
You mean which part?
Fit knn.fit,
Okay,
yes.
yeah,
Did you
this.
use? Yes. Just below that matrix we have used min Kosi.
Okay, no. This is actually use Euclidean distance.
Okay, but matrix just below that line in matrix is equal to mean quotient. What does that means?
Where is that?
Go little right, scroll little right.
Okay,
Yeah,
okay,
matrix.
okay. This is default. This is default. Minkowski is default. All right. Minkowski is actually default. All right. So if explicitly I could have done it over here, I could have done this thing, this matrix over here. All right. And then use just write it over there. But if you don't use it, by default, it will just show you that, right? That's why I say you don't actually need to do that, but they all arrive at the same solution. The distance measures are just going to arrive at the same distance measures. It's just this different way of calculating the distance.
So hello.
Yes, hello.
So here the weights is equal to distance. That means it's in Euclidean distance.
I did not get your question. Can you measure it again?
In that same line of code where it's
you mean the dot fit or
below that line,
below?
yes, weights.
Okay.
Weights is equal to distance. Here.
Okay, you mean here?
Yes.
Okay, what this part is saying is that give weight to the distance. Okay, so let me bring the pen and then show you something.
So can I change distance here? Means mentioning the other distance.
Yeah, there's several parameters that you can actually tune over here. So let me show you what all the various parameters that you can show. If you use distance here, right, then it's saying that if I have data points like this, if I have data points like this and that and that and that and that and that and that, right, something like this, and then maybe maybe another some other points like this, and then a new one comes in like let me use green. Okay, let me use green. Let's say this is the new data point that has come in, right? So what distance here is saying that give weight to the distance between this new data point and any other data point, right? So the ones that are closer to it is more important than those that are very, very far from it. So if the data point is far from it, it means that it's less similar to it. But if the data point is closer to it, it means that it's more similar to it, all right? There's other way that you can tune this. There are a lot of them. Let me just show you in a brief. So I'm going to show you this one, KNN classifier. All right, let's see the official documentary. Then you can see what is inside there. Now you can see over here, right, where I use weights, all right? So default, they will use uniform, right? They will use uniform, and uniform means that all points in each neighborhood are weighted equally, all right? So it doesn't matter where the point is, whether it's far or near, they are all having the same importance, right? But if you use distance, right, if you use distance, it means that weight points by the inverse of their distance, right? In this case, closer neighbors of query points will have a greater influence. All right, so those that are closer to it will be having more, will be placed with more importance. All right, that's why I said always, if you want to tune the parameters, you can easily go to the documentary, and then you can, the documentation, you can easily see the parameters.
So here, what is the difference between distance and callable? Just below that distance, you can see that callable is written where user-defined function which accepts an array of distance.
Yeah, it means that you can also write your own distance there. You can also customize it. You can also customize it. They have several examples that you can follow, and then you can see how they are tuning the parameters. So this is what they call the hyperparameter tuning, all right? Where you can use one algorithm like this. Instead of maybe using several algorithms, you can only use KNN, right? And then keep on changing the parameters, right? Keep on changing the neighbor size, the weight, the algorithm, everything. You keep on changing them till you get the the best accuracy. All right, so you can keep on changing them. So for using a particular algorithm like this, you can easily refer to the documentation and then see the various hyperparameters in there that you can actually be changing. All right. Okay, so going back, what were we doing? Okay, so I said I'm going to show you how you choose the K, right? So what was the, okay, I'm actually going to store these things. So I'm going to test several K, right? And I'll store it in this. So I'm going to use some for loops. All right, so let me use for K. Okay, in range. So I'm going to give a range of Ks, right? Since I don't know the kind of K that I want to use, I'm going to use maybe from K equals 1, K equals 2, K equals 3. So I'm going to use maybe up to K equals 50. Right, so I'm going to test up to a huge number. And then let me see what I can do. Let me do, okay, first I named it, algorithm was just KNN, right? Yeah, it was just KNN. So I'm going to do KNN1. Let me do it like that. KNN1 equals, then I'll bring the same thing here. I'm going to do the same thing again, but this time I'm going to, instead of specifying K equals 5, I'm going to change it to test for different Ks, right? So I'm going to use K, just K, right? Because I'm saying that K is in this range. K is in range 1 up to 50. So it's going to test different Ks from 1 up to 50, right? Then I'm going to use the same thing over here. So let me run that. Then after that, we did, this is the next step that we did. So I'm going to do the same thing over there. So this is KNN1. All right, then I'll do that. Then after that, let me put everything in this score so that I can plot it and let you see. So I'm going to do scores, or maybe I just did score, right? Append. So I'm going to add everything here, dot append, KNN1. Then if I check the score on the S test, all right. Let me check how it's doing on the, sorry, on the S test and the Y test.
So here neighbors is equal to size, cluster size, or the separation between the data sets.
Okay, so here neighbors equals K, and K is from 1 to 50. So neighbors equals 1, neighbors equals 2, neighbors equals 3, neighbors equals 4. It's going to do that a lot for us, all right? It's going to do that, it's going to check all of that. Okay, so I run this, and then I can now plot this. plt.plot, and then I'll set same range over here. And I'll put score. Let me see. Okay, let me go down there. X and Y must have the same dimension, but have, okay. Let me see what I did. Score. KNN1. Okay. Let me rewrite this thing again here. Let me just try this thing again here. Name it scores_1. Let me put this thing here. I'm going to use this. Okay, so this one is good. So let me plot this thing so that you can see, then I'll explain to you what I'm doing here. Let me set the figure size. Figure size equals, let me give it like 10 and 8. Okay, so I'm going to use matplotlib to plot this. Set the range. And then I'll use this one. Or maybe this. Set the color. Say color equals blue. And then I'll use the line style. Line style, I'll use dash. I think it's dashed. Okay. And then the marker I'll use O. And then I'll use marker face color. Then I'll use red. And then I'll set the size of this marker. I'll set it to say 10. And then maybe I'll set the X label. Because X label, I will name it say K. And then I can also set the Y label, plt.y label. And then for that, I'll name it as accuracy. Maybe I can even set the title. So plt.title. See, rate, which is values, right? So k dash values. Maybe, yeah, it's fine. Let me see. Keyword argument repeated. Okay, let me see here. Comma marker. Lines down.
Yes, marker used 2 times. O, marker O and marker 10.
And marker what?
Marker equal to O. We have used O.
And then marker
After
what?
that again marker is equal to 10. The last one is marker 10.
Okay.
It will be once, right? It will be once.
Yeah, I'm using actually using marker face color. I'm using marker face color. I'm using marker.
What is the last parameter? Marker 10. Yeah, marker 10.
Okay,
just,
okay. All right.
Remove this marker.
Yeah.
Okay.
Supposed to be marker size. That's what I wanted to write.
Yes, marker size, right.
Wanted to write marker size. Okay, let me see what is happening again. MySD object has no property marker face color. Okay, so let me go and see. Oh, I missed R there. It's supposed to be marker like this. What else is wrong? Okay, it has plotted, but there was something model match plotted the by plus no model Y label spelling again over there. It's Y. Okay, it's supposed to be this. Like that. Okay, everything fine now. All right, so let me show you what went on and then what we are doing over here. I think this one was this one. Let me go and use that again. I think I missed that, so that is why it was doing that. It was giving us some error somewhere. So whatever the case may be, I just want to comment that part. What was this one? Okay, so let me comment that one. Let me comment that one out. And then just comment this one. Okay. So now we can use this one to test. All right, so this is one way of actually seeing the best K to choose. All right, this one way of seeing the best K to choose. Okay, now what happened is that we are testing different K here, right? We are testing from the range of 1 to 50, right? From K being 1 all the way to K being 50, right? So K is 1, 2, 3, 4, 5, 6, 7, all the way to 50. All right, that's what is happening here. And I mean, testing the K, right? Let me bring the pen so that I show you what is happening over here. K is giving us, if you use different K, you get a different performance, all right? So being K equals 1, all right, is this one. We are getting some, maybe 94. This is the percentages, this is the accuracies, right? So 95, 95.5 or 96%, 96.5%, 97%, all right? So if K equals 1 is giving us maybe here 90, maybe we can say 93% or something like that, right? Maybe 0.93, that's 93%, right? So K equals 2 all the way. I mean, it will just test it a lot, right? So you achieve the best K that is giving you the maximum percentage, right? That is giving you the maximum percentage, then you can choose that particular K, right? So if let me enlarge this a bit. Let me try and enlarge this a bit, and then I can draw some line from the best one all the way down. I can increase this size here, figure size. Instead of 10, maybe I can do it like 20, 10. All right, then I'll run it again. This one is a bit spread out. It's a bit spread out, so let me bring this and then get the line. Okay, so now let's trace to somewhere here. All right, so maybe K equals 8, all right? So we can test K equals, between K equals maybe 8, 10, 12, all right? We can check something like that and see which one is giving us the best K, all right? So around that area is when we will get, if we go beyond that, we see that our accuracy will begin to drop again. So from here, the accuracy will increase, it will start to increase, All right, so it gets to 97%. That is the maximum accuracy that we can get. All right, so then it will start to decrease. All right, then it will start to, so if we choose K to be very, very large, like say K equals 15, 20, 30, or something like that, then we see that our model will begin to decrease, right? But if we test K between 8 and then say 12, 13, we can see that our K will actually do well. All right, our model will actually do well. But if we go beyond that, our model will begin to fall down, right? Our performance will begin to fall down. So instead of me using K equals 5, let me go and do it again and then choose K, different Ks, which are between say 8 and then maybe 12, 13 or something like that. And then I'll get the best case. So here I'm going to change. So our accuracy was, let's see the accuracy we got, 96, right? So let's change the K to be say 8 and then run it again. Now I'm going to do the same thing and check the accuracy again. I'm going to do the fit, then run it. Now let me go and then check the score again. You see that now we have 97%. We have 97%. Now I'm going to run it again using different K, not this one. I'm going to run it again using a large K, maybe K equals, let me use K equals 20, then run it, and then check the score. Oh no, I have to fit again. Let me fit again. All right, then I'll check the score again. Sorry, I'll check the score again. See, let's see, it's giving us 97. All right, it's still giving us 97. So between 8 and 20, it's still doing quite good. Let me move to K because say 30. Let's see. Let's run it again. It's now reducing to 95, right? Let's go to K equals 0.5. All right, it's now stable there, 95. It's not coming up again. Let me choose K equals 50. It's not going to do any well better again. All right, so that's a way of checking to get the best K to choose. All right, so you can just use just the simple code. All right, it's just if you want to build a different model, or I mean on KNN, right? You can just use this, and this is just over here is just the name that you use, right? This is just a variable. You can even maintain it, right? And then you check. You can be using this over and over again, right? You can be using over and over again. The only thing that you're going to change over here is this stuff, right? It's just this, the name that you give. If you give the same name here, then this one is still going to be the same. But S scaled DF is what we did over here. So if you name your data set differently, I mean your scaled data differently, then you need to change that one respectively, right? Like this. If you remember, we scaled everything, and then after that, we converted to data frame and we stored it here. So we can be using the same function over and over again to check. This one is just checking 10 different, running it 10 different times, just checking it 10 different times, and then giving you the overall accuracy here. All right, so you can just be using the same thing to plot it over and over again to check the different case, all right, the different case. So in this case, I choose very high because I wanted to actually know when it would start dropping and when it would do well for me, all right. So although I chose K equals 20, it was still performing that, but I will not choose that. I'll choose between here, between maybe 8, 10, or something like that. That's so what I would choose for K. All right. Is there any question? If there's no other question, we can end it here. I think we have exceeded the time. way too much.
Hello.
Yes, hello.
Yeah, I have one small, quick question regarding this k value odd and even. From the graph itself, that's event. If we choose k some even number, its accuracy is low, and if odd number, its accuracy is high. So I do not understand what is the actual reason behind this.
Okay, this one is to keep, you don't actually know the kind of key that you're supposed to choose, right? You don't actually know the kind of key that you're supposed to choose. So this one is just to give you an idea about around which area you're supposed to choose your key, all right? Around which area you're supposed to choose your key. So in this case, if you choose K to be, say, maybe I should choose K to be, say, 3, something like that, right? If I choose K to be 3, I get 97%, all right? But if I go beyond that and then choose K to be very, very high, I'm getting very, very low accuracy, right? I'm getting low accuracy. One thing you have to also note that although you can get high accuracy, this is just a testing data that you're using to test the model that you're performing. But if a new data comes in from, maybe you build this thing and you deploy in a website like a platform like Amazon site, right? And you get new data, it might perform differently. Then you need to come back and see that, okay, I choose K equals say 3, or I choose K equals say 21 or 17, all right? And it was giving me this kind of accuracy. So I'm going to change it again and then use different accuracy and then you test it. So there's something called A/B testing too that you have to also do, right? That if you choose, even if you choose K equals say 20, which is an even number and it's performing the same way, you should also think about the other side that if you deploy it on a real world situation, there's going to be a tie where the model is going to find it difficult to assign it. So automatically it will just assign it to one of the classes, which maybe you might not want it that way. That's why I'm saying that it's better if you choose K to be an odd number, all right? So instead of maybe, in this case, instead of maybe choosing K equals 10 or something like that, you can choose K equals say 13. All right, so that will make more sense when you deploy this model. Okay. If you have any other question, you can ask.
Hello.
Yes, hello.
Please go a little above. Yes, sir. There.
Okay.
So here in plot.plt.plot, what is marker is equal to 0 means you pointed that data.
Okay, the marker is not 0, it's O. It's O, like letter O.
Marker is O.
It's just a symbol to say that, where is my pen? Okay, let me pick this, red. Okay, it's O, right? That's why it's a string. That's why I'm putting it in a string form, right? It's O, like yeah, it's O like this. All right. So that's why you see point here. You see it as O in a form of, like, it's just a form of showing it that show it in a point form. Show all the points in this format. So these are the markers.
Okay, so you control the size, color, and shape, right?
Yeah, it's just the color and the shape, and then the dash here is, that's why you're seeing dash.
Okay.
Yeah, they are just something you can just do by hand. That's what I'm saying, that you can just maybe like plt.plot like this, right? If you see it from the documentation, you can see all these things there. You can see the things that you can actually do by hand. This one, I did it because I wanted you to see the points, right, and see where it is getting low and where it's getting high.
So
and the
yeah,
size here is just
this O shape can be triangle, square, and circle, right?
yeah,
These
yeah.
3 types.
These are just shaped, these are just kind of, this just marker type that you can use. So if you see the documentary, there are several different mark types that you can use. And here I'm using dashed, and there are different ones that you can also use. All right. Instead of saying dashed, you can use different one. If you see the documentation, you can get a lot of them there. They are all just customizations you can do by hand.
Hello.
Yes, hello.
I want to know about that. How much knowledge is required in the field of data science regarding data structures and algorithm? Uh, I have not belong from any computer science background, so does it really require to get all those knowledges regarding data structures, algorithms, and then to build knowledge in here particular language in Python? Uh,
Okay. I am also not from computer science background. I learned it just like you're learning it, all right? And the only thing that will get you know to get to know the thing is practice it, right? So like I was just writing it, right? Like if you see up here, I wrote it, the one that I just, let me just open it. Like these ones that I commented, right? All these things, I mean, I was just writing it because I've written it some several times in some other projects, right? So doing this one, I know what I'm supposed to use. I know that if I use marker equals 0, if you use the color equals red and stuff like that, it's going to look nice and you're going to see it, I mean, very nicely. It's something that I've practiced before, right? So it's all about practicing over and over again. That's why I stress on doing a lot of projects, right? If you do the projects and continuously doing the projects, you'll get to know it. Like this one, maybe I use this one, you think that's O or 0 or something like that. You just use, just check plt dot plot, just check on the documentation. You get to know that, oh, this is a letter, this is something like this, so I can also use this. If you use this 2 or 3 times, you can write it without looking at any other code or something like that. That's why I stress on doing projects a lot, right? That's why I stress on. So it's not about you coming from computer science background or something like that. Python is just logic. It's how you write it, it's how it's going to deliver it to you, right? So it's not like Java or C++ or C sharp or C itself that you're going to actually need to know the logic behind, follow some syntax and some, I mean, it's Python is not like that. You can just write it according to your own logic and according to how you want it. So it's not, you don't actually need to come from a certain background before doing these kind of things. It's just about practicing it over and over again.
okay,
And that's why I
and
stress mostly on doing projects. And the main reason why we did the other program, all right, so that will be mainly focused on doing projects over and over again, so that the students will actually get to know the concepts.
okay, and how much knowledge regarding SQL and Excel will be helpful in data science? Because I also don't know about SQL.
Okay, if you know, as you should just know as much SQL as possible. All right, you just, and SQL is just basic stuff. I mean, considering Python and the likes of Hadoop and those stuff, SQL is just is as simple as that. SQL is just querying, right? Just I mean, SQL is not anything difficult that you should even worry yourself about. I
But
mean, if
most
it is
of the
SQL, it
job,
would have been done by now.
to get a job in data science, most of the job
You need
asking
it.
about.
You need SQL, because what happens is that this Python and this new stuff which is coming in, right? It's all new to companies. Companies have their data stored in a database, and you need SQL to query those data and then bring it in a structured format, like maybe in an Excel sheet, all right, or maybe, I mean, in a CSV format or something like that. It's 11 o'clock. If a company is having their data in a database, then you need structured query language to actually query the data and then get it. That's why they stress on you getting an SQL skills. All right, but SQL is something that you can learn within a week or two and then get familiar with it. That's why it's all about practice and practice, right? It's not anything difficult. SQL is not something that you should actually worry yourself about. But you need to know as much SQL as possible because most of the companies have their data sets. I mean, their data stored in the database. That's why they stress on it. If you can query their data, get it in a structured format, in a CSV format, and then help them make analysis on it, then you are the kind of candidate they want. So the basic skill is to know SQL as much as possible, know Excel as much as possible, know Python as much as possible, and then know machine learning concept as much as possible. All right. And for you to get to know these things is all about practice, doing a lot of projects, practicing a lot. If you do it over and over again, when you see the problem statement, you know what to do. So
Okay,
yeah, don't worry too much, but practice a lot. If you practice it a lot, you actually get to understand it. It's not about your background or something like that, right? Those languages are not hard to learn. If you are doing something like Java or something like JavaScript or something like that, then you actually need to
does
know about
JavaScript
maybe the
helpful
background.
for data science?
No, 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 no. We are not going to do that. You only need to know as much SQL as possible, as much Excel as possible, as much Python as possible, and then the machine learning concept. And if you want to move further to deep learning and those stuff, it's okay, right? And if you want to take the lines of big data, then it's also having some other languages that you might also learn. But Java
So
and Python,
are
yeah.
we going to learn also SQL later?
Yeah, you will get access to an SQL. I mean, there will be a whole tutorial on SQL which I'll make it available for you.
Okay.
Okay, is there any other question that anyone wants to ask? Okay, if there are no other questions, then we will end the class here. All right. Okay, thank you. Good night.